Hello, welcome to Anson Griffin's occasional series of YouTube tutorials featuring Matlab. Today I'm back to one of my favourite topics, image processing in Matlab. And just for the record, this is video number 228. So this caught my eye, and just to say that the intellectual property belongs to Matlab and MathWorks, and in particular this guy Martin here. So Martin Potts was trying to segment an image. There we have the original image. Martin shows how to do a segmented for 9 colors there, RGB to index. There's using a Kmeans cluster, and there's used the Martin Potts energy. So I decided to run that myself and see how I got on. So that's what it's about. Just to say, if you want to get more detail about the methods that Martin used, there's the Matlab file exchange page. And down there, just where I'm highlighting here, where you would find some papers giving the details of the Potts method. Okay, so I downloaded it, I installed it, etc., etc. And you can see here as I flip around the screen, there's the code there. I just wrote it as a script, but I also publish it, so I'm going to look at the publish method here. So the code here is in grey, yeah, so I tidied up. I read in the image, and I just took this suggestion here with 9 clusters. And I use one segmented method using the RGB to index command there. And it's just on the line above. So you return 2 variables x in the map, and we display there using that index method. Get back to Matlab now in a second. And the elapsed time to run that was 0.017 of a second, which is the same time as Martin got. Then I did a Kmeans clustering. So we picked out the red channel, we picked out the green channel, we picked out the blue channel, and then we did a cast operator there to get it into, a 2-dimensional array with a number of rows and with 3 columns. I used the Kmeans. I've talked in more detail here about the Kmeans and the various options that you can use. There's the command that I ran there. And there I've displayed, I reshaped it to get it back into a 3-dimensional image, the red, the green, the blue channel. And I displayed that there. And it's not great, to be honest, and that took 4.32 seconds. Now, slow down here a little bit. The only thing when I ran this here, not in that code that I showed you, I had to use a cast operator here to convert it to double. That wasn't mentioned in the code from the MathWorks blog site. Now, I don't know whether that was because I'm using a different version they were using, but I had to use that cast operator. And when Martin ran it himself, he resized it halfway in the X, halfway in the Y, so that would end up as a quarter the original size. And he ran that using the 2 pieces, using the 2 functions that he wrote there. The one function twice. So displayed that Potts image, and there it is. Now remember, this is half in the X, half in the Y, so it's a quarter the size, and I got 1.62 seconds, which is a good bit different from Martin. And then I ran it using the full size, again having to use the cast operator double. It took 6.36 seconds, which is about 4 times, which is about right, what you'd expect. And there's the segmented image there. And that looks a lot better there than, say, the Kmeans. Just go up here a sec. Kmeans looks fairly brutal, to be honest. And the RGB to index method there. So Martin's method for this example here of the lighthouse is a much more effective method to segment out the image. Hope that helps for listening, and thanks very much. Bye.